So we're going to begin our discussion of data and what statistics is all about by talking about the different types of data that you will encounter. But let's step back and ask ourselves, what is statistics? Statistics is the study about how to best collect, analyze, and draw conclusions from data. So data is the key component of statistics. Statistics has developed relatively recently. Really, it's only become formalized in the past 80 to 90 years, really in the 20th century. But the foundations of statistics, it lies much earlier. It lies 1,000, 2,000 years ago. One way to think about what statistics is all about is to put it in the context of the general process of scientific investigation. We can think of the process of scientific investigation as entailing several steps. The first step is to identify a question or problem. The second step is to collect relevant data related to this question or problem. The third step is to analyze the data that you just collected. And the fourth step is to make a conclusion. For example, you might say, will aspirin help stop my headache? So you might identify a question related to aspirin, which is, will it stop my headache or not? Then you might collect relevant data on the topic. So you might take an aspirin on a particular day when you have a headache, and you might keep track of whether an aspirin helps stop a headache or prevent a headache or reduce the symptoms of a headache. And then you will analyze this data after collecting several years or weeks or months of data, and then you'll make a conclusion. You might say, well, aspirin works for some people, but it doesn't work for me. We do this process of scientific investigation every day. It's really in our bones. It's natural for most people. For example, you might say, does working out in the morning make me more energized? You might say, will eating a watermelon relieve my thirst? Some students will say, they'll ask themselves, when they're taking a course, they'll say, if I study 1 hour a day, can I ace the final exam? Or people who want to lose weight, they'll say, if I just avoid cream with my coffee in the morning, will that help me lose weight? The key point here is that we do this all the time. Everybody asks these kinds of questions, and informally, people collect data, even if it's just a set of observations in the world around them, and then they come to certain conclusions. So we really do that all the time. We go through this general process of scientific investigation. The goal of statistics, however, is to take this general process of scientific investigation and improve it, especially steps 2, 3, and 4. The collection of relevant data, the analysis of this relevant data, and the process of making a conclusion. The idea of statistics is to make this entire process, steps 2, 3, and 4, more reproducible, reliable, and rigorous. To put it another way, statistics is about improving the process of scientific investigation. Substantively, that first step differs depending on your background. So for this course, where we're really focusing on topics in the social sciences and humanities, we're going to focus on questions or problems that a social scientist or a historian or an anthropologist might ask and address. But before we really investigate that, we should ask ourselves what data really consists of. Data are just a set of observations. These observations can be collected in various ways, such as through field notes, surveys, and experiments. There are lots of different ways to collect the data about the world around us. In the social sciences and humanities, we often have data on people. If you go to different subject fields, such as biology or physics, you don't always have people as your set of observations for your data. But in the social sciences and humanities, data are often centered around people. Now, you might encounter this sort of grammatical issue about whether you refer to data or datum. The singular form of data is datum. So that's one bit of data. It's a data point. So you might say that datum is very low. That data point, that particular observation is very low. Data is the plural form, but it may be used with a singular or plural verb. So both are grammatically correct. You can say the data were analyzed after they were collected, or you can say the data was analyzed after it was collected. So when we're talking about data, sometimes people will correct you and say that you're using it incorrectly, but you can use data, even though it's plural, you can use it with a single or plural verb. So let's talk about some of the real-world examples that we're going to encounter in this course. So substantively, we're going to focus on topics in the social sciences and humanities. These are some of the questions we're going to ask ourselves and answer in this course. One of them is, do kids think sports is important for being popular? Or do kids think that money or good looks is more important for being popular? Were men more likely than women to die on the Titanic? And another question we'll talk about is, could we have predicted who won the 2008 presidential election in the United States? These are all questions that social scientists and humanists have actually asked and addressed, and that we're going to explore in this course. Let's focus on a little bit on this last question about predicting who won the 2008 presidential election in the United States. In 2008, the two presidential candidates were Barack Obama and John McCain. This is a map of the election results. In the United States, the president wins based on the number of states that he or she wins overall. And so in this map, the blue states are those states that Barack Obama won, meaning he got a greater percentage of votes in those states, and the red states are those that John McCain had won. But let's suppose you go back in time to October 2008. This was before the election in 2008. In the United States, the election is held in November. So let's go back just 1 month previous to the election and say you are a political analyst, a political scientist, and you collect data on the characteristics of U.S. states, and you want to predict who will win what state. Will John McCain win or Barack Obama? And this is a kind of analysis that people have actually conducted in the past, and people continue to conduct in order to predict electoral outcomes. But let's step back and say you have a research assistant for this project. How does your research assistant organize all these observations about all these different states? Because you need to organize your data before you can analyze it. Well, in statistics, we have a very transparent way of organizing data. We organize data into something called a data set or data frame. A data set is the same as a data frame. The rows of the data set are called cases or observational units. Sometimes the rows are referred to as simply observations. The columns of this data set are called variables. Variables are simply characteristics or traits of the cases. To put it another way, each row is a different person or state or other kind of observational unit, and each column is some kind of characteristic or trait for each one of those observational units. So this is the data set that our research assistant has collected for looking at U.S. states. The cases are U.S. states, and the variables, the columns, are the characteristics of U.S. states. When we have a data set or data frame, we like to keep track of the cases, especially when we have a very large data set of 1,000 or 1,000,000 different rows, then it's important to keep track of your different observational units. So in our case, we have 50 states. It's not particularly large, but it's still useful to keep track of the different rows. What we use to keep track of the different rows is we use this little letter I. And this little letter I is an index, and each row has a different value of I. So you might say, well, what is the case or observational unit if I equals 5? Well, that's California. That's I equals 5 refers to that entire row. What is the case if I equals 49? Well, you just go down to the row labeled 49, and you see that that row is in fact Wisconsin. One question you might ask is, how many cases, how many observational units do I have? Well, that is just simply the total number of rows. We call that a little n when we're talking about a sample of data. So our data set in this case says n equals 50 cases. The index that we use goes from I equals 1 to I equals n, where n is the total number of rows. It's the total sample size for a sample of data. So in this case, n is 50 because we have 50 states. Now, one thing to keep in mind is that there are many different kinds of cases that you will encounter in your research and in your analysis of certain kinds of data. Cases, that is the rows of the data set, they can be everything from respondents who answer a survey to subjects involved in an experiment to records of transactions or different kinds of inanimate objects. If you're a historian, each row, each observational unit might actually be a different historical event. So in the social sciences and humanities, we encounter lots of different kinds of observational units. But in general, you will encounter that the rows are typically people and the variables are typically characteristics of people. That's because in the social sciences and humanities, our subject matter often focuses on people. So let's think about some of the columns of the data set that we have for our data set of US states in 2008. Each of the columns, they're different variables or characteristics of the state. So that first column is called state. That's the name of the US state. The next column is region, so that's just the geographic region, whether the state is in the west or south. Then we also have this column for population. This variable gives the population in millions for each state. And then we have this variable high school. That gives the percent who graduated from high school for each state. So these variables are different characteristics for each observational unit, each case. One thing you should keep in mind is that you should be careful of the units of measurement for each of your variables. So for example, if we look at our data set, you might ask, well, what is the population of Alabama? That's that first row. You should keep in mind that it is not 4.53 people, it is 4.53 million people. That's because the units are in millions. So if it's unclear what the units are for different variables, you should always ask the person who collected or organized the data. So we've talked about a few of the different kinds of variables, but there are actually two main types and then two subtypes for each of these main types. We can think of variables as either being qualitative or quantitative, or to put it another way, we can think of variables as being categorical or numerical. It means the same thing. When we talk about a numerical variable, sometimes people will call that a quantitative variable. When people talk about a categorical variable, sometimes people will call that a qualitative variable. But it's useful to distinguish between these two main types of variables. Numerical variables, they are variables that simply take on values that are numbers. So for numerical variables, it usually makes sense to add, subtract, or take numerical summaries such as averages of these values. So some examples would be an age of a respondent, the miles per gallon in a car, or the ranking of different colleges, in which, suppose you have 4 colleges and you want to rank each of these 4 colleges from 1 to 4. Well, each college gets a 1, 2, 3, or 4 ranking. For numerical variables, it's useful to further distinguish between continuous numerical variables and discrete numerical variables. For a continuous numerical variable, it can be assigned, it can take on any number. So, for example, height in inches, or percent of children living in poverty, or the number of miles you might have moved away from your childhood home. Each of those variables are continuous in the sense that it makes sense. It's possible to have many decimal places. So your height in inches might be 70.23589 inches. In contrast with discrete variables, discrete numerical variables, they can take on values that are only non-negative counting numbers. So 0, 1, 2, 3, 4, 5, and so on. So these kinds of variables, discrete numerical variables, they have certain jumps between each of the values that it can take on. So a discrete numerical variable cannot have a value of 1.5. It doesn't make sense. It can't have a value of 3.42. It only can take these values of non-negative counting numbers. So some examples might be the number of votes for a politician. When you count votes for a politician, the votes are non-negative counting numbers. A politician might get 3 votes or 500 votes or 1,000,000 votes. But a politician can't get 3.5 votes unless there's electoral fraud going on. If you look at a sort of a different example, if you look at the rating of a restaurant on a 5-point scale, assuming that scale just consists of 1, 2, 3, 4, and 5, that is a discrete numerical variable. Another example would be the count of the arrivals at an airport. So how many arrivals occur at an airport in a given day? Well, that's going to be a count. That's going to be a discrete numerical number. You might have 500 arrivals at an airport, but you won't have 500.5. So the key point between continuous and discrete numerical variables has to do with whether or not they can take on all sorts of numbers or just non-negative counting numbers. So let's go through a few examples. The annual household income of a respondent in thousands of US dollars, that's an example of a continuous numerical variable because you have these decimal places that dollars can take on. A rating from 1 to 4 stars of a movie, assuming that the stars are 1, 2, 3, and 4, that's a discrete numerical variable. To give another example, the number of murders last year in a neighborhood would be a discrete numerical number because for that kind of variable, you only can take on 0, 1, 2, 3, 4, and so on. Besides numerical variables and their two subtypes of continuous and discrete, it's useful to talk about the other main type of variables you will encounter, which are categorical variables. Categorical variables, sometimes called qualitative variables, they take on values that have different categories or qualities. Sometimes you'll hear a categorical variable referred to as a factor, and the different categories or qualities that a categorical variable can take on are sometimes called levels. It means the same thing. If somebody talks about a factor with different levels, they're talking about a categorical variable with different categories. Here are some examples of categorical variables. Gender of a respondent. In general, it would be male or female, so you have these two categories. You might talk about approval or disapproval of a social policy. Or you might talk about whether somebody's a regular smoker or not. So yes or no, do you smoke regularly or not? These different kinds of variables are categorical in the sense that there are these different categories or qualities. The two subtypes of categorical variables are nominal and ordinal. For nominal categorical variables, there's no inherent order to their categories or levels. So for example, religious identification, political party affiliation, or the names of countries you have visited in the past year, each of these nominal categorical variables, they're nominal because there's no inherent ordering. It doesn't make sense to say that for religious identification that Catholic is somehow higher or lower than Protestant, for example. So for nominal categorical variables, there's no inherent ordering. For ordinal categorical variables, there is usually an expected ordering. It's sort of natural or inherent ordering to the different categories or levels. So for example, you might talk about the highest educational degree a person has attained, or the level of approval in a country's economic policy, from strongly disapproved to strongly approved. Each of these ordinal variables, they have an ordering to them. So when you talk about the highest educational degree someone has obtained, a graduate degree is naturally higher than a high school degree. So, or if you talk about approval, it makes sense to order the different levels so that strongly approve is the topmost category, then below that might be somewhat approve, and below that would be somewhat disapprove, and below that would be strongly disapprove. For ordinal categorical variables, it makes sense to order the different levels. However, it's not always clear-cut, because one person's idea of what a natural ordering is, it might be culturally specific. Maybe if you go to a different person or a different society, there is no inherent ranking that's obvious to people for different levels of a categorical variable. So keep in mind that if you're unclear about whether a categorical variable is ordinal versus nominal, you should probably stick with it being nominal, just because in ordinal variables there's a certain subjective component to saying that certain levels are higher or lower than others. For this course, we are going to talk about the different subtypes of numerical versus categorical variables, but we will focus in particular on this main distinction between numerical and categorical variables. That's the key distinction. It's useful to know the subtypes, but the sort of main data analysis decisions that you make for this course will be based on whether you have a numerical variable or a categorical variable. So let's look at our data set of states again. So as a reminder, the rows are the observational units, are US states, and we have these different characteristics, these different variables of each of these states. So let's go through our columns of our data set and say what type of variable is each column. That first column is state. It's the name of a US state. That is a categorical variable, and it's nominal. And the levels of this categorical variable are the different names of the states. You might have Alabama, Alaska, Arizona, and so on to Wisconsin and Wyoming. For that column, it's nominal because there's no inherent ordering to the levels. And it's categorical because we have these different qualities or categories for that variable. If we go to the next column, we have this variable for region, geographic region of the US state. This is also categorical, and it's nominal because there's no inherent ordering to the levels. The levels, or the categories here, are northeast, midwest, west, and south. So we have 4 levels for this single categorical variable. For the variable high school in the 4th column, this gives the percent who graduated from high school. This is a numerical variable because we have these values of numbers, and it's continuous because it can take on decimal places. So the values are different numbers such as 90.2 and so on and so forth. And then let's look at this other variable of population in millions. This is also numerical, and it's continuous because it can take on decimal places as well. Let's look at our data set and just summarize. So we have two categorical variables and we have two numerical variables. Both of the categorical variables are nominal and both of the numerical variables are continuous. So for this first part in our discussion of what a data set really consists of and our introduction to data, you should know that a data set is really just consists of a set of observations about the world around us. When we take sort of raw observations and we organize them into a data set, we call that a data set, sometimes known as a data frame. The rows of a data set are the cases or observational units, and the columns we call variables. They're characteristics of the cases. And then in general, variables may be numerical or categorical, and then among numerical variables, we like to distinguish between continuous and discrete variables, and among categorical variables, we like to distinguish between ordinal and nominal variables. And with that, we will end our discussion for now about what data sets really consist of and the different types of data you will encounter.